one thing I wanted to mention about absolute value is one of the important definitions in calculus has to do with absolute value when you're talking about what's called a limit. So you'll see that again, certainly in that place in regards to calculus. So first of all, absolute value, I'm going to do a very quick review of what it is. And really, it's a distance. And absolute value is the distance between the number and 0. That's all it is. A lot of times students don't think of it that way, but that's what it is. So the absolute value of 5, all that means is it's the distance from 0 and 5, and you know that distance is 5. Okay, so what you've learned is the absolute value of a positive number is already 5. Okay, and you got that. All right, and you don't necessarily have to draw this on the number line, but it's just basically you're 5 units away. That's all that is. Okay. The next one, absolute value -3, it just means how far is -3 from 0? Well, again, that's 3 because it's a distance. Distance is always considered to be positive. So what this would mean technically is just what is this distance between 0 and -3? That's why it's a positive number, okay? So what you all learn is that the absolute value of a negative is a positive, okay? And then the other possibility is do absolute value of 0, which just means the distance from 0 in itself, which is 0. Okay, so the distance is 0 in that case. So that's kind of what you get with absolute value. You want to think of it as a distance, and that will help you with the problems we do, and it'll certainly help you in calculus when you do that definition of a limit to think of it as a distance. So a couple of real simple things on this. We know that distance is always a positive number. The smallest distance is 0, so you'll never get a negative answer when you're doing a distance. So distance can never be a negative number. Okay, so that's kind of the idea. So it kind of goes like this, real simple. Absolute value of a positive is just equal to the positive. Absolute value of a negative changes to positive, and absolute value of 0 is 0. Okay, and that's all there is to that. I wanted to just give a kind of a quick little review before we get into the formal definition of an absolute value. Okay, so these are just some different absolute value expressions. So absolute value of 13 is 13. Absolute value of -7 is 7. Absolute value of 0 is 0. That's what we reviewed. What's the answer to D? I do have a negative in front of absolute value, so what's the answer? -13, right. You know the absolute value of 13 is 13, but that just reattaches like that. Because technically what that means is -1 times absolute value of 13. Okay? How about the next one, E? I see students mess up on this all the time. Is that 7 or -7? It's got to be one of the two. -7, exactly. Okay, so the absolute value of -7 is 7, but then again that reattaches, okay? A lot of times students will see negative and they'll think positive. Not in this case, okay? It's just, it's the opposite of an absolute value. And then the last one, of course, is 0. Can't be anything else, okay? So what I want to talk about a little bit is the formal definition. Students understand absolute value and how to do that easy enough, but a lot of times don't understand the definition. So the definition is the absolute value of A is A if A is greater than or equal to 0. So what this really means is this. Like if I just chose a number for A that's bigger than 0, all that says is you just take off the absolute value symbol. That's what that says. Or if A is 0, it just says take off the symbol. That's what that says. Absolute value of A is A just means the symbol comes off. Okay, but it's totally different if A is negative. So what you do if A is negative is, say for instance, A is -2. Well, according to the definition, you do the opposite of what's in absolute value, so that's equal to 2. Okay, that's the formal definition of that. So it's just saying if A is positive, remove absolute value and be done with it. If A is negative, what do? You change that negative to a positive. Does that make sense? Does that definition make sense? Sometimes reading these definitions can be a little confusing for students, but everything that we do in this section is based on that definition. That's the idea, okay? Okay, so what we're going to do is we really do 3 things in this section. We do equations, and we do inequalities, and then we do some basic applications, all right? So the first thing we're going to look at is absolute value equations. Okay, what's the answer to the first one just in your head? How many answers are there? Let me ask that question. Is there one or two? There's two. What are those two answers? 9 and -9, right? Okay, all right, so I was making sure. Okay, and the idea is typically, not always, but when you do an absolute value equation, you'll typically get two answers, but there's times when you don't. How about the next one just in your head? There's two answers, so let's see, what would be the two answers, or at least one of them? -4, that's good. Okay, that's good. What else? There's another one. -8. Did I hear somebody say -8? Okay, good. Okay, so we're going to learn how to do that. The idea is if you do -4 plus 6, that would end up giving absolute value of 2, so that's 2. And then if you plugged in -8, you would have -8 plus 6. Well, that's absolute value of -2, so it's equal to 2. Okay? So in a sense, what you try to do when you solve an absolute value is you try to figure out what causes it to be 2 and what causes it to be -2. That's how you end up getting your two answers. Okay? So what we're going to do first of all in this, I'm going to take this example and just show you the strategy that you use that's always going to work on an absolute value equation, because most of the time you can't do it in your head, so you have to go through a process. So the first thing we're going to do, I'm just going to take this example. This has kind of got a little bit of everything in it. The first thing that you always do is isolate the absolute value. That's, to me, is the most common thing that students do wrong. And if you don't take the time to do this, you'll generally end up getting one of your two answers wrong. So what you have to do is get the absolute value by itself. So you'd have to get rid of the 6 and the 2 in order to isolate that. So it's just like you're solving an equation, because you are solving an equation. So subtract 6 from both sides. Then that would end up just giving you 2 absolute value x minus 4 equals 4, like that. Okay, then what you want to do is get rid of the 2. You get rid of the 2 by dividing by 2. You don't want to distribute. You really technically don't want to go through and distribute through an absolute value. Particularly if that was a negative, it would mess everything up. So just divide both sides by 2. And if you do that, you would get x minus 4 equals 2. Okay, so that's step one, is always to get that isolated so you have an absolute value equals a number. That's always your goal, okay? Don't do it any other way, because if you forget to do that, you're going to mess up. So what we do now is, just like the last problem that we did in our head, ultimately you had to figure out on this problem what made it 2 and what made it -2. So that's what you do, is you set up two equations. You say x minus 4 equals 2, and then you also say and, or it doesn't make any difference, x minus 4 equals -2. Okay, because remember, you're taking the absolute value of that -2 anyway. So now once you get it set up, it's easy to solve. So now it's just solve the equation. You can get down to this point, you can do this in your head. X equals 6 would be one answer. That if you go here, add 4 to both sides, you would end up getting x equals 2. So those are the two answers to that equation, are 6 and 2. So isolate, then set up your two equations. That's kind of the key that you do on that, okay? And let's check these. These sometimes are easy enough to check in your head, so let's just go ahead and check on these. And always go back to the beginning when you check, so just plug in the 6. So we'd have 2 times absolute value of 6 minus 4 plus 6 equals 10. And then you would want to check the other one, which is 2 times absolute value of 2 minus 4 plus 6, and see if that's 10. I want to check because I want to show you why we set up the equation the way we do. What would end up happening is this would be 2 times absolute value of 2 plus 6 equals 10. That certainly is easy enough to do in your head, so that one certainly works out. The next one, you would get 2 times absolute value of -2 plus 6. Well, that's still 2 times 2 plus 6, so that's still 10, isn't it? Okay, so the thing is, what we ultimately figured out is what value of x made one of them 2 and one of them -2. That's the idea. Does that make sense? That's why we do those two equations. All right? So that's how you do that, and you have the ability to check on these problems. So most of these are going to be very straightforward. There'll be a few little issues that pop up on these problems as we do these now. Okay. Okay, so let's do this next one. I want you guys to go ahead and take time yourself to do these two problems here. I want to see what you come up with, particularly on B, but go ahead and do that yourself. I'm going to put 2 and 4. I'll show you. Okay. So let me run through this first one. First of all, make sure you do this okay. You got to isolate first. So subtract 6. You would end up getting 3x minus 9 equals 4. Then you set your two equations. 1 equal to 4, 1 equal to negative 4. So your equation, if you get that set up, you shouldn't really have trouble getting the answer as long as you can get it set up okay. All right. Well, the answer is not negative 2 and 4 on this. I suspected a lot of you did this. On B, what you do is you add 6 to both sides, and you end up with absolute value of x minus 1 equals negative 3. Okay? If you went through and did this, and I suspect some of you set it to negative 3 and set it to 3 and solve, well, they don't check. Okay? They don't check. Here's the way I look at this. I stopped the problem right here because I know the answer. Is it possible to do an absolute value and ever get negative 3? No. So what's the answer to this equation? No solution. Okay, that's what it is. Now, if you did it this way, you just got to check your answer, but it's unnecessary. Okay, so the idea is you can never have an absolute value equals a negative number. That doesn't work. So this one is no solution. And you can always kind of correct mistakes by checking, but those two answers, negative 2 and 4, do not check. So what I suggest to a student is if you see an absolute value isolated equals a negative, you're done. It's impossible. Okay, does that make sense? Okay, all right, so that's something you have to pay attention to. All right, so let me go to the next page then, and then we'll do a couple more of these kind of things. Some of them can be quadratic. They can also have fractions in it, so I wanted to do one kind of like this. So on this part C, this is already isolated. So what you would do is you'd set up your two equations. Your first equation, you would say x over 2 minus 3/5 is equal to 1/3. And see, when you take that out of absolute value, don't write it in an absolute value, take it out. Then the other one would be x over 2 minus 3/5 is equal to negative 1/3. Now, I know that's got a solution because it's equal to a positive number. If it was the same problem equals negative 1/3, I'd say no solution and be done with it, right? Okay. So what I would do on this problem, I would suggest that you get rid of the fractions. So what would you multiply by to get rid of a 2, 5, and 3 at the same time? Common denominator time. What is that? 15, right. Okay, so we want to multiply both sides of these equations by 15. Okay, and then that will force us to get rid of our fractions and everything on there. Well, 15 doesn't work because 2 doesn't go into 15. What's better? $30. How about 30? Okay. I was thinking 15, but that's no good. So we want to try 30. 30 will get rid of all of them at the same time. Okay. So multiply this by 30, and then multiply the right side by 30. Okay. Now when you do this, you can do this in your head if you want to, or you can write the step. This would just be 30x over 2. And then that would be, if you want to, you could say 90 over 5, or you can just say 30 times 3/5 and then cross out the 30 and 5. And then the next one is 30 over 3, which is equal to 10. Okay, so if you did this, you would end up having, it looks like 15x minus, let's see, 30 over 5 is 6. That would be 18 equals 10 like that. Okay, that gets rid of the fraction. Now you can add 18 to both sides. So that would give 15x equals, it looks like 28. Okay, and then divide by 15. So it looks like one of your answers is going to be 28 over 15. You don't want to get a decimal. You just want to get a reduced fraction. And that's good enough. Okay, you would do the next one exactly the same way. Just multiply by 30, both sides. And you can do this in your head if you want to. This is 30x over 2 is 15x. And then when you do this, 30 over 5 is 6. 6 times 3 is 18. And then this just becomes negative 10. Okay, just getting rid of your fraction. Now you can add 18. Okay, and then that'll give 15x equals 8. Then you can divide by 15, so your second answer is just going to be 8 over 15. Okay, so if you got fractions, get rid of them. Use the common denominator and get rid of it. So it's the same basic idea. Okay, everybody with me there? Okay, we've done that before. We've reviewed how to do fraction equations with fractions. Okay, now the next one's quadratic. And what you want to do on this is, what we've been doing is you want to make sure absolute value is isolated. It already is on this, it's isolated. So what you're used to doing is setting up two equations, okay? But it's unnecessary in this problem. There's no need to go x squared minus 7x plus 10 equals negative 0 because it's 0 anyway, right? But it's still the same idea. You just set those equations up and solve. That's what we'll end up doing on the next problem on E anyway. So this one is unnecessary. How do you solve this equation? Probably by factoring. It's quadratic, so this one looks like it'll factor. Okay, so if we do this, that would be x and x. It looks like you would go 5 and 2 to get 10 with two minus signs. So what are the two answers, it looks like? 5 and 2, right. Okay, so you can do the rest in your head. You never have to write down this step unless you feel like you need to. So you have x equals 5 is one answer, and x equals 2 is the other answer, like that. Okay, so it's just a quadratic equation that you can put together. Okay? Okay, let me kind of do the part E in here. It's the same idea. Absolute value is isolated. There's nothing in front of absolute value, nothing outside of it. So you immediately just set up your two equations. So you say x squared plus 5x minus 3 equals 3. And you can solve that. Maybe it'll factor. We'll see. Then the other one is x squared plus 5x minus 3 equals negative 3. Okay, and we'll just basically solve those and see if they factor. The first thing to do on this is probably to get one side equal to 0. So I'm going to subtract 3 from both sides. So I'll get x squared plus 5x minus 6 equals 0. So it looks like that factors. I'm pretty sure it does. So that would factor as x and x. You would have to actually use 6 and 1 on this, and then a plus and a minus to get that to factor. So the two answers to this are going to be x equals negative 6 and x equals 1. So that generates two answers, but then we got the other quadratic to solve that could possibly give us more answers. Okay, and then this one I'll do the same thing. I'll get one side equal to 0. And in this case, both things cross out, giving x squared plus 5x equals 0. Okay, how do you factor x squared plus 5x? Factor out an x. I always ask that question because students a lot of times forget about common factors. Don't forget about common factors. Take an x out. So that would give you x times x plus 5. So what are the two answers to that equation? 0 and negative 5. Okay, so we're going to end up getting 4 answers to this problem then. That's because it's an absolute value equation. That's what generated more answers on that. And they all check. Okay, the thing about this is, well, actually, I'm wrong about that. One of them, you're going to look at the checking on this second one, and you're going to run into some problems on this. So you got to kind of look at this checking on these things. So let's go through and check out these. These are okay. If you plug in negative 6 and 1, it's going to check out okay. But let me show you what happens when you plug a 0 in. So if you go back to the beginning of this problem, actually, I think we'll be okay on that. Now that I think of it, because actually if we go back and plug in 0 into the very beginning, I think I was looking at the wrong thing when I was thinking about that. Is this going to check? Okay, yeah, that checks okay. And the negative 5, I'm pretty sure the negative 5 checks. It's just you got to take the time sometimes to check these. So you'll have negative 5 squared plus 5 times negative 5 minus 3. And we'll see if that's equal to 3. Okay, so that would be 25. That's going to work also. 25 minus 25 minus 3. So that's absolute value of negative 3, so it's 3. Okay, so everything checks. There's going to be instances sometimes when something won't check, so it's worth going through and looking at when you're solving these equations. Okay, so that's absolute value equation. Is there any question about what I've done there so far? You got something?
So once you factor it, how do you just know that the two factors are going to be the answer?
Yeah, well, you're setting each factor equal to 0. What you're trying to do is figure out what makes each factor equal to 0, because in this equation, when you have x times x plus 5, if x is 0, then 0 times x plus 5 is 0. So you're always, when you get it factored, your goal is to figure out what makes that factor become 0. I haven't been writing the step out because most of the time you can do that in your head okay. But on this problem, you could just say, okay, set x equal to 0, and then set x plus 5 equals 0. Okay, and see here's the thing on this too, is if you look at this, 0 times anything is 0. So that's why x has to be 0. If x is negative 5, then that whole thing becomes 0, and 0 times whatever that is 0. So you're always just kind of looking at what makes each individual factor become 0, because the product's got to be 0. Okay? Now before you do the factoring, you got to make sure one side's equal to 0 in order to use that then. Yeah.
You said that sometimes one of the factors will check. If that happens, do you leave it out?
You just throw it out if something does not check. Okay? And that'll happen sometimes. Kind of depends on the situation. Everything's okay with this one, but it's always worth on these kind of problems where you have quadratic to check. If it's not quadratic, you'll be okay. You know, most of the time, unless, you know, that one that we did that had no solution would be kind of the exception to that. Yeah.
So does that basically explain why they're called zeros of the function?
There you go. It's exactly why that is, okay? Because what they're doing is they're causing that whole quadratic function to be 0. Okay, so that's what's happening. Okay. Okay, so anything else you've got a question about? Okay, now the next thing we'll look at then is the inequalities. And again, the key on this is know how to set these things up. What I've given you here is more or less a summary. I'm not going to go over this, but this is a summary of the different inequalities, their interval notation, and the graph, like that if you need to review that. We'll be kind of looking at this as we do examples, but I wanted to just give you something to refer to if you needed to, okay? So let's go to the next page and let's do an absolute value less than. We're going to break this up into two things. We're going to look at absolute value less and absolute value greater than. And you want to understand this. You know, if you understand it, then you can get the setup put together okay. So we're going to look at a real simple one and just see if we can figure it out in our head, okay? So here's kind of the idea on this. What I'm going to do is we're just going to write down some numbers that work, okay? Just start kind of plugging numbers in. Well, if you plug 0 in, that obviously works because 0 is less than 3. If you plug 1 in, 1's less than 3. If you plug 2 in, 2's less than 3. If you plug 3 in, you would end up having absolute value of 3 less than or equal to 3. That's okay because it's equal to 3, right? How about 4? What happens if you plug 4 in? Then it quits working, right? Okay, so what you would have is once you get past 3, these numbers here don't work anymore. So we're going to kind of look for a pattern on this and kind of think through this. Now let's do some negative numbers. Sometimes students will jump to conclusions and think, well, all the negative numbers work, but they don't. They quit working at a certain point in time. So if you did -1, that's definitely true, right? -1 works. -2, that definitely works. -3, that works because 3 is equal to 3. But what happens if you go to absolute value of -4? Does that work or not work? It doesn't work because that's 4, and 4 is not less than 3. So what will happen is it stops working once you get below -3 like that. So when you have an absolute value less than, what tends to happen is your answers tend to be between two values. They're kind of in the middle of two things. So the way that we would do this graphically is we would just say, on a number line, we just do this, and we draw a picture like this. It would be bracket on -3 and 3, then we would shade in the middle like that. So that would be the graphical solution of that absolute value. Okay, and in interval notation, we would just say -3, 3. So it's all the numbers in between -3 and 3, including -3 and 3. And that's what you're going to have on an absolute value less than problem. It's very predictable. If you had absolute value of x is less than 100, then what would it be? It would be between -100 and 100, right? Okay. What will change, though, is we'll change that expression inside absolute value to something else where you can't just do it in your head like this. Okay. So the idea is going to be if you have absolute value of x less than a, then the solution is just parentheses -a to a. If you have absolute value less than or equal to a, then the solution is the same. It's between -a and a, but it's got brackets to include that. Okay? So that's the idea. If you forget how to set these problems up, just go back to a real simple problem like the one I just did. Okay? Now, the key thing on absolute value inequalities is when you set these up, the first thing is to isolate the absolute value. Just like we did on an equation, if you forget to do that, then you're going to mess up with part of your answer typically. Okay? Then you set up the inequality. You usually make it between two values, and then we end up solving for x. Okay? What we're going to do then is isolate the variable in the middle. Then we write the solution typically in an interval notation. Okay? So here's what you do on this one. If you got, it is a less than, this absolute value is isolated. So you set it up like this. What you do is you just write down the 4k plus 3, take it out of absolute value, and you put it in the middle of two numbers. You put it below 6, and you put it above -6 like that. And you're going to see me setting up all of these less than problems that way. And then the idea is we got to solve for k, getting k by itself in the middle. We call this a three-part inequality. So now what you would do is you got to subtract 3 from all three parts. Don't forget to do that. So then you would have -9 less than or equal to 4k. And then that would be less than or equal to 3 like that. Okay? Then what do? You got to get the 4 away. So you divide by 4. And then we'll have what we're trying to get then. Okay? And you'll have fractions on these problems a lot. So what we'd end up having then is we would just have -9/4 less than or equal to k less than or equal to 3/4. So those are the two numbers that it falls in between. Okay? And what you'd want to do is you'd want to graph, and then typically we're going to do set builder notation and interval notation to put these things together like that then. And generally on a graph, what I want to see is just 0 and estimate where these numbers are. So, 3/4 is between 0 and 1. -9/4 is -2.25 or -2 1/4. So I'll just go all the way out to -3. And then I just kind of estimate where they are. So 3/4 is in here, and you're going to have a bracket, right on where you think 3/4 is. And then -2.25 is going to be roughly in there, and then you just shade in the middle like that. So that's how that goes. All right. Okay. Now the way we would write our answer is in set builder notation. Set builder, you want to be flexible how you do this. We would just say the set of k. K is our variable, and then we would just say exactly what we got. We have -9/4 less than or equal to k less than or equal to 3/4. And all that means is k is in the middle of those two numbers. Okay? Interval notation is just like the graph. You would say bracket -9/4 comma 3/4 bracket, and that would give you a solution like that. Okay? Now, these problems are 100% verifiable, which is worth doing a couple of times as a student. If you just plug in the -9/4, it would give you 6. And if you plugged in the 3/4, it would also give you 6. And every number between -9/4 and 3/4 would work in that inequality. Everything outside of that wouldn't work. So that's the idea. Okay? Okay, what's the first step on the next problem? Got to isolate. How do you isolate? Subtract 4. Okay, don't forget to do that. Okay, I see students forget that all the time on these problems. Okay, you got to start that way. And when you do that, then you would have absolute value 3x plus 1 less than 9 like that. Okay, then set it up. So the setup goes like this. You would say, just write down the 3x plus 1. And what are the two numbers you put it in the middle of to start with? Negative 9 and 9. Okay, so you start that way. It's always the number and the opposite. And then what you got to do is get x by itself in the middle. So we would subtract 1 from each part. Okay, that would give negative 10 less than 3x less than 8. And you divide by 3. Each part gets divided by 3. Okay, so you'd end up getting negative 10 thirds less than x, and then less than 8 thirds like that. Okay, same idea. After you isolate, get it set up, should be fine to get your solution. And this would kind of go like this. Let's see, 8 thirds is really 2 2/3. Negative 10 thirds is really negative 3 1/3, or you could change them to decimals if you wanted to. So what I would have you do on this is just locate 0. You need to probably go out to 3 and out to negative 4. And then you just estimate. Okay, on this problem, am I going to use parentheses or brackets? Because I have just a less than. So what's that tell you? Parentheses. Okay, use brackets if there's less than or equal to. Okay, so this is going to go like this. Estimate where 2 2/3 is. And then estimate where negative 3 1/3 is. And then just shade in the middle like that, and then that would be your graphical solution. Okay. For set builder notation, you would just say set of x, because x is our variable, and then you would just say negative 10 thirds less than x less than 8 thirds. Okay, and then for interval notation, it would just be parentheses, just like the number line graph is we have. So we'd say negative 10 thirds, comma 8 thirds like that. And that's the idea. Okay, so if it's less than, that's how you set that up, is you set it up between two numbers. Does that make sense? Do you guys okay? Usually what students do on these sometimes get everything backwards with greater than and less than. Less than is a small distance, so it's between two numbers. It's going to be totally different when we go to greater than. Okay? Okay, now a lot of times on these problems you get into some kind of special cases that you have to think about when they pop up. So what this one is saying is, this is saying the absolute value of x is less than negative 3. So this, you just think about this in your head. The question is it possible for an isolated absolute value to ever be less than a negative number? Just think about that. If you do the absolute value of x, you're always going to get 0 or something positive, right? So that's impossible. X, if you take the absolute value of a number, it will never be less than a negative. So the answer to that's no. So what's the solution to this problem? No solution. Thank you. Okay. All right. See, when you start having an absolute value and then a negative, things kind of fall apart. You wouldn't want to set this up. Okay. Well, I want to show you one thing on this problem, because a lot of times I see students do this. Let me show you what happens. If you set this up the way I just taught you, I said put it less than negative 3 and then put the opposite. That's nonsense. Okay, if you look at that, you're telling me that 3 is less than negative 3. Okay, so if you set it up that way, I hope you would see that that's nonsense. Okay, so you don't do anything except just do that in your head and see that it's no solution. Okay, all right, let's look at this one. Now with this one, we're less than or equal to 0. Okay, so let me ask this question. Is an absolute value ever less than 0?
No.
No. Is it ever equal to 0?
Yeah.
Yes. In your head, what would make this equal to 0? Negative 5. Okay. This problem's going to have one answer, and it's only going to have one answer because it's less than or equal to 0. Now, if you set it up, let's just set it up the way I've been teaching you. You could say x plus 5 less than or equal to 0, And then you could say negative 0. But negative 0 is just 0 anyway. Okay? What you'd end up doing if you did it this way, and sometimes students will do it this way, you would end up getting basically negative 5 less than or equal to x less than or equal to negative 5. That's an interval, but that interval only has one number in it, right? You're going from negative 5 to 5. So what you would have is your solution. In set builder, you just say this. You can just say, if you want to, negative 5. If it's only got one answer, that's how you write it in set builder. Okay? And then interval notation, well, you could write it as bracket negative 5 bracket. You just don't typically need to do it that way, though. So typically on a problem like this, you just have one answer. And that's what will happen if you have an absolute value less than or equal to 0. Okay? It's totally different if it's greater than or equal to 0, though. Okay? So that's kind of the idea. All right, any questions on those two examples? Okay, so like on your homework, you'll see some of those pop up, and you want to do them quickly and be observant when they do. Okay? So what we're going to do next is do this backwards. And I always kind of start out this way. All of the absolute values were between, right? What's the opposite of between two numbers?
Outside.
Outside. One going that way, one going that way. So absolute less than's kind of here. Absolute value is this way. It's just the opposite, because greater is the opposite than less than. So if you were doing this problem, this is what would happen. If you listed solutions of this, well, 3 would be greater than or equal to 3, so would 4, so would 5, and so forth like that. Okay? But then you would find stuff like 2 wouldn't work, 1 wouldn't work, 0 wouldn't work, negative 1 wouldn't, negative 2 wouldn't. How about negative 3? Does negative 3 work in this inequality?
Yes.
Yeah. Okay, because it just says absolute value of negative 3, which is 3, that's equal to 3. So it works, and then it'll start working from then on out. So that's why I was saying it's kind of the opposite. So what you'll have on this is you'll have all the numbers going that way, then you'll have all the numbers going that way. Okay, and you'll have that gap in the middle. It's the opposite thing then. Okay, so the way this would go on a number line, your solution would go like this on this problem. You would go out to 3, you would go out to negative 3, and then your graph would look like this. You'd have a bracket at 3 going to the right, bracket at negative 3 going to the left. Okay, like that. So if you write this answer in set builder, you would say this. You would say set of x, and you would say x is less than or equal to negative 3, or x is greater than or equal to 3. Okay, it's not between two numbers anymore. In interval notation, it would be negative infinity, you're going to the left infinitely, comma, negative 3 with a bracket, and then it would be 3 to infinity. And then you use a union symbol to join those two like that. Okay, if you need to review your interval notation, that's something that you'll do in this section. And that's real important in calculus, is to, because you'll work with inequalities and intervals all the time. Okay, so that's the idea. Does that make sense why the solutions are going that way? Okay, so when you learn this stuff, think of absolute value less than as between. Think of greater than as this way, all right? And that'll help you remember how to set these things up, okay? Okay, so this is basically kind of what happens on this is if it's an absolute value greater than, like on this one, absolute value greater than A, it would go like this. You would have A, and then a solution going to the right. You'd have negative A, and a solution going to the left. If it's got an equal to, greater than or equal to, it's the same thing. It's A, but at this time it's a bracket. Then you would have negative A going to the left like that. Okay, so absolute value greater than problems are going to be set up that way with two separate inequalities. That's the idea. Okay? Okay, so to me on these problems, if you learn how to set them up correctly, you're not going to have any trouble getting them right, because then it's pretty standard equation solving stuff. Okay, any questions about anything? Okay, so I've kind of written down the steps that you would do on this that you can refer to if you need to. So I'm going to work out a couple of the absolute value problems then. and see how you do with this then. So the first thing on this one is you have to isolate. Isolate's always the first thing, so you're going to subtract 6 from both sides. So that's going to give absolute value x minus 5 greater than or equal to 5, like that. And then you're going to set up two things. So I always kind of think of it this way. One solution goes to the right, so you would say x minus 5 is greater than or equal to 5, and then you would solve that. The other solution goes to the left, so you have to do two things. Going to the left is less than, and then you change the 5 to negative 5. So that's what you always do, is greater than the number, less than the opposite of the number. That's the setup of that, and once you get that set up, then it's pretty easy to do then. Okay, so if I solve this, I'd add 5 to both sides of the inequality, and that would give x less than or equal to 0. Okay, then if you go to the other one, you would add 5 to both sides here. And what that would give you is that would give you x greater than or equal to 10. Okay, that's the idea. All right. So what you would do on your number line is usually all I want to see is I want to see 0, and then I want to see whatever those numbers are. So I'm going to just go out there and call that 10, and then your graph would go like this. You would go to the right of 10 with a bracket, then you would go to the left of 0 with a bracket like this. Okay? Now let me show you on this problem how you can check and tell you're right. This is something that when you do your homework, you got to try to train yourself to do. Seriously, if you plug 10 in, you can do this in your head. So what's 10 minus 5? 10 minus 5 is 5, right? Absolute value of 5 is 5. 5 plus 6 is 11. So that worked. Plug in 0. 0 minus 5 is negative 5. Absolute value negative 5 is 5. 5 plus 6 is 11. See? A lot of times you can plug it in and see if you're right. And what would happen if you took like a number bigger than 10, it would work. Like if you took 11. 11 minus 5 is 6. 6 plus 6 is 12, but 12 is greater than 11, right? That's what happens. Same thing would happen here. If you plugged in numbers less than 0, they would work. All the things in the middle would not check out. So if you understand that, that kind of helps you understand the problem. Okay? So the way you would write this in set builder is you would just say set of x, and then you write your two inequalities that we got. We got x less than or equal to 0, or x is greater than or equal to 10. So that's the set builder answer. Interval goes like this. You would say negative infinity to 0. That's your less than. Then the other one would be 10 to infinity. Okay, one of them's going to the left, one of them's going to the right. That's the idea. Okay? All right, so you can get it set up. Shouldn't have too much trouble. Okay? So let's do this part B here. This one's already isolated, so you don't have to isolate. You would set this up like this. The first thing you would do is you would do 9y plus 18 over 2, and then you would say less than negative 9. That's going to give the solution going to the left. Then you would say or 9y plus 18 over 2 is greater than 9. That would give you the solution going to the right. Okay? So, well, you got a fraction, so how do you get rid of the fraction on this problem? Multiply by 2, right? The only denominator you have is a 2, so it would be kind of wise to just multiply both sides of this equation by 2. And then once you do that, it's pretty easy. So we'd have 9y plus 18 less than negative 18. Okay? And then you could subtract 18 from both sides. And that looks like that would give 9y less than negative 36. Then you could divide by 9. And that would give you y less than negative 4. So the solution going to the left is to the left of negative 4. Then you do the same thing over here. You just multiply both sides by 2. Okay, and after you do that, you're going to end up with 9y plus 18 greater than 18. And then from there, just isolate the y, so you could subtract 18. That would give 9y greater than 0. Divide by 9, so the other solution going to the right would be y greater than 0. Okay, so that's it. Once you get it set up, it's pretty easy to do. So graphically speaking, we would just go to negative 4, go to 0. So you would be less than -4 with a parenthesis, and right of 0 with a parenthesis. Okay? And then set builder is just the answer we got. So you would just say set of y. Now you have to pay attention. The variable is y in that problem. So we'd say set of y with y being less than -4 or y being greater than 0. Okay? Interval notation is just like the number line. It starts at -infinity, ends at -4. That's your first solution. The second one starts at 0 and goes to infinity like that. So you're going to find on these absolute value, structurally, they all kind of are going to have the same kind of look to their answer. Okay? And the key thing is this number, after you isolate, is positive. And then that's pretty much a guarantee. If what's inside the absolute value is linear, then you're going to have a solution going that way, a solution going that way, and a gap in the middle. Where it starts messing up a little bit is when you have that negative on the other side. Okay, that's when you start getting into the weird cases. Okay, any questions about what I did? Okay. All right, so let's look at these special cases here, and then there's a couple of things on the last page that we'll look at also here. So this one just says absolute value isolated greater than -3. So here's the question that you ask yourself. When can an absolute value be greater than a negative number? It always is, exactly. Okay, good. So really the way I look at this problem is this side is always bigger than -3, correct? So what's the answer to this problem? If it always works, what's the answer? All real numbers. Interval notation, -infinity to infinity, okay? So yeah, it'd just be everything. Everything works on that. And you just set builder, you just say x. You can just say x is any real number. So it goes like that, okay? So you want to kind of get these things straightened out in your mind. You don't want to memorize it, just reason it out. No matter what you plug in for x in that problem, it'll always end up being greater than -3 because you're taking an absolute value, okay? Okay, the next problem, now we got a 0. And when you have a 0 there, that kind of affects things a little bit. So let's think about this a little bit then. Okay, no matter what you plug in for x, you're going to get what kind of number there? Positive or what? What's the smallest that side will ever be? 0. Okay, so basically this problem is just saying, is that strictly bigger than 0? Okay, it almost always is except for when x makes that 0. So it's going to be everything except what makes that absolute value 0. Okay, now here's one thing you can do on this. If you're ever in doubt on these problems, you can always set them up. So let's just set it up this way. Let's just say 4x minus 5 is greater than 0. Then let's say or 4x minus 5 is less than -0. Well, -0 is 0 anyway. Okay, so if you solve these two inequalities, let's see, you would add 5 there. So that would give 4x less than 5. Then you'd divide by 4. So you'd end up getting x is less than 5/4 like that. So that's definitely a part of the solution, is you're less than 5/4. If you go over here and add 5 to both sides, you'll end up having 4x greater than 5. Then if you divide by 4, well, you get x is greater than 5/4. Okay, now on a number line, what this would be is it would be every number except what? 5/4, exactly. So on a number line, it would just go like this. You'd kind of think of having a bubble on 5/4, and then you would just be to the right of that, then you'd be to the left of that. It's everything except 5/4, okay? So the way you would write this then, there's several ways you could write this. You could say set of x, and you could say x is not equal to 5/4. If you just write it that way, you're implying that it's everything but 5/4. That's okay. In an interval notation, you just have to say -infinity to 5/4 union 5/4 to infinity. The parenthesis is what excludes that one answer like that. Okay, the problem is 5/4 makes it 0, but everything else makes it positive. So that's the idea. Does that make any sense? Okay. think about it, but again, on each of these problems, you can always just set them up, and you'll end up getting something on there that gives you the answer fine if you just set it up that way. Okay, any questions?
How do you write that in step builder?
I just said x is not equal to 5 fourths.
Okay, so you just write.
Yeah, you could say x, or you could just write a sentence. You could say x is any number except 5 fourths. That's okay. Okay. All right. So let's stop there then, and we'll finish up this next page on Wednesday. And you'll get your test back. Your test will be posted either late tonight or tomorrow afternoon. I'm done with part 1, but not part 2. So I should have time to maybe wrap those up today or tomorrow.